Hello, people. Hope you're doing fine. Please wait some seconds. I'll be here really soon. Hey. Okay. Do. Okay, hello. Hello, people. I hope everyone's doing fine. Yeah, it seems to be streaming. Perfect. Perfect. Let me maybe just reduce the volume a little bit and we'll be going. Okay, let's hope this is fine. Hello, people. Hope you're good. And today we'll do something a bit special. And actually it's not going to be about this. It's going to be... wait. It's going to be about my other project. It's not going to be about the card game. It's not going to be about the game, actually. It's not really a game. Well, maybe it's gonna be, but not now. It's gonna be about the ball that's bouncing. I want to generate a mesh. Because I don't have enough time to even think about what I should do for my game, for my card game. So you know what? So here we go. Here we go, and if we run this, we should have a ball that bounces. Whoa, right? Here we go. That's good, right? It's like very good. I like that. But now I have to actually make a mesh. Yeah, that looks... okay, that's really good. I have to make a mesh out of this, right? And I guess clean the code a little bit too, but that's another another part, let's say. So what do I have to do? Let's open Google. Enable subscribers only mode. Wait, what? I did? When did I do that? No, I didn't. What? Wait, I enabled... wait, when? What? I did? What the fuck? Okay. Anyway, that's good. Godot. Let's go in Godot. And let's what? Let's generate mesh. I guess I actually kind of have an idea because I already did that on my first game on Godot. We have something called mesh instance, and inside we have the mesh here that we can, you know, select, right? And we have things like well, immediate mesh maybe, also array mesh maybe, and then we also have point mesh, I suppose. A single point primitive, maybe actually just array mesh. Array mesh should be good. We actually have a whole page about it. And immediate mesh is not the thing I want to use. It's like OpenGL1. The OpenGL1 API, I guess it's gonna be array mesh, right? Because, well, let's see first. So, array mesh. No. Extends mesh. A few different quality of life functions. And most importantly, the ability to construct a mesh surface through scripting. Oh. I feel like I have an idea. Well, I have an idea of, well, of difference. Mesh data tool is a resource that converts mesh data into arrays of vertices, faces, nana. Okay, that's great. Surface tool allows the creation of meshes. That's shit. Yeah, that's... Okay, so I guess I'm gonna use like everything, like just array mesh, well, not everything, array mesh and mesh data tool. I think that settles it. So we have this, create from surface, potentially. And then we have this. So we can go down, we can set up the array, let's do this. Let's do generate mesh, maybe. Generate mesh. So we are gonna have the surface, or like, and this will be the array that will keep our surface information in. It will hold all the arrays of data that the surface needs. So inside I'm gonna put, oh, okay. I guess they're just references then. So I'm putting the, yeah, it's the arrays, the buffers. So it looks like, it looks like this, okay. Generating a rectangle. So I have a few things, I have the vertices. I don't need the points right now. Well, the UVs, I mean, I don't really need the UVs right now. But I'll be able to set them, I suppose. Then we have, do we have the normals? Yeah, we do. Okay, interesting. Wait. Yeah, okay. And then there was indices. Rectangle generation code looks like this. Okay. Generating a sphere. I mean, I'm gonna have a sphere, right? So that's not really a sphere, but kind of. So that's kind of appropriate, I suppose. Saving. We can save. Yeah, what about? Okay, I'm generating a sphere, but what after that? Array mesh, right? So we have all of this, and we just add surface from arrays. No blend shapes, LODs, or compression used. Primitive triangles. Looks good to me, I suppose. I mean, let's do this, I suppose. I'm just worried about something. Godot array mesh update vertex position. Because we have to update at one point, right? You need to retrieve the surface data arrays, modify the vertex, then commit the changes using add surface again or set arrays. Consider using the rendering server. I mean, maybe just using the rendering server is gonna be better. Rendering server. Advanced efficient. Yeah, it's using the OR IDE, right? Rendering IDE, I guess. Is it? Resource Unix identifier, never mind. Use the rendering server to update mesh surface update region. That's what I want, because I don't want to reallocate new arrays every time, because that's gonna consume some performance. I don't want this. Immediate mesh is like never. So rendering server. Let me check. Godot rendering server create mesh. So yeah, I create the geometry. Wait, SC surface tool. Yeah, I can do this. Primitive triangles, add vertex, and then we can generate the normals. Oh, that's great. That's actually great. Wait, do I? Okay, that's. I suppose that's fine. Is it? Let's say it is. So we're gonna have constraint, key position. I guess we have the circle here, right? So then we're gonna have, well, yeah, the mesh. Oh, we're gonna have the surface tool, I suppose. So surface tool equal new. Then we're gonna begin. Oh, begin. And well, okay, mesh dot primitive triangles. Primitive triangles. Should I do this? I mean, I can do lines too. It's gonna be a circle, right? So I guess I would have to go back to the center every time. I mean, I have to make sure this is the center. Yeah, how do I even compute the center? I mean, I just... Because, I mean, if it's like bouncing, then it can be like concave, right? Planet. Okay, never mind. Let's just do this for now. And then at the end, I'm gonna commit, I suppose. So like here, I'm gonna commit. Wait, what? What's commit to arrays? What's this? Oh, okay. Further process the mesh data using the array mesh or importer mesh APIs. I'm just gonna commit. I'm just gonna generate the normals before that. Should be good. And then just thinking a little, but yeah, should be good. And then we have basically I'm going to add the vertices, right? Wait. So global position, well, key.position. So I mean, technically, I guess I can just loop through the keys, right? Key.global position. So I'm adding child to this, okay. I mean, it's gonna fall, but not the current. Wait, is the current thing gonna fall? I don't think it is. The current node, I mean. So that means, what does that mean? Just remove this. Move that down because I already computed the position of the keys. And I'm just gonna do for I in range. So this is gonna be this, I guess. Global position. Look good to me. Hi, hello, do you have problems? How are you? How are you doing? Sorry if I was a bit late. I had the documentation on the right side. I'm not working on my game this time. I'm working on the bubble. This thing. Ooh. So yeah, if you have any question about it, feel free. It's using soft, well, it's using some soft physics, it's called. It's like used for like skin, for like jelly, for like I guess a lot of. Oh, really hello. How are you? Coucou. Comment tu vas? I actually thought about something incredible. I actually realized that I could just stream during the morning instead of the night. Wait, did you leave already? Oh. Yeah, because I mean, like right now, I'm just, you know, going to sleep at like 3 a.m., I guess. But instead, I could wake up 3 hours earlier and I could just stream. I could just stream from like, I don't know, 8 a.m. to 11, maybe, something like that, right? Or maybe not even stream, I could just be here. You're insane. What? Am I? I'm just destroying my shape right now. Okay, that's fine. But yeah, just stream forever. Spring joins or something. Wait, it's soft birdie. Spring? No, it's not Springs. Springs is, well, actually, well, I guess. Let me think. Let me look at it. It's not. Well, it's basically, I guess, connected, right? So that's what that's why it looks bouncy. It's using basically some joints, I guess you could say. Um, Connects two 2D physics bodies with a spring-like force. Yeah. So yeah. Okay. Yeah. Yeah. Technically, I guess it's springs. Yeah. Yeah. Thanks. And yeah, today we're just generating the shape around it. Try to generate the mesh using the array mesh. Because, you know, the shape is not the same every time, right? But we need some visual. And we need some shader to run and, you know, to have like some really nice looking shape. So that's what we're gonna do. And we're actually going to use a curve that's called the... I forgot. There's like two names in one name. Type of curves. Okay. No. What is it? Simple, open and nah. That's it. Hyperbola. What? What are those? Degree 4. That's not. Wait. No, that. Devil's curve. Wow. Yeah, that's not really what I want. None of that is. Butterfly. Wait, that actually looks great. I didn't know about this page. That's the first time I go here. Round. Spirals. Fractals. Okay, do we have... No, we don't. Too bad. I think I have the name on my Discord. What was it? I think I had a link on my Discord a while ago. Raw something. Raw something. Raw damp curve. Okay, let's try. Curve. Raw. Blah blah blah. Chat doesn't find it. That quasi something form looks a lot like the P shell in chemistry/physics, or D shell, one of those. Oh. I was actually, maybe I should find it. Well, maybe I'm gonna find it if I look at my liked videos. Sorry for removing the music. Here we go. So, oh no, Robert something maybe? Procedural animation. Oh wait, no, that's. Oh wait, wait. Portal to Pocket Dimension. No. What's the deal with procedural animation? Let's open this.
Procedural animation.
Oh no, shit, that's bad. Bad one. Splines in 5 minutes. Oh, Catmull Run. It's the Catmull Run. Catmull Run. It's this one. And it looks a lot like a Bezier. It's actually some kind of Bezier, I guess. But the goal is that we can have automatically the tangents. That's the difference between that and the Bezier. So yeah, should be that. Hi, lurking. I'm bad. Oh, I'm lucky. Okay. Okay. So now we have mesh dot. No, we have the vertices. So I guess it's surface tool dot push dot vertex add vertex. Yep. Cannot resist the classic dad joke. I mean, who can? Well, who can't? Well, who? Yeah, right. Who can't? 3.new, is that? No, that's like this maybe? Yeah. So now we're gonna have to make a triangle. So triangle is made out of 3 vertices, right? So it's kind of, I was gonna say simple. We have the current index. We have the next index, which is I plus 1, modulo the size. It's not very optimized, but that's fine. And then we have the center. And the center, I guess, is going to be kind of 0 right now. Oh, sorry. Yeah, let me just... okay. So we have this one. Well, actually, we can remove the vector. We have this with I. We have this with J. We have 2, 2, 2. The middle, the one in the middle. Actually, I think there's like something for that. Wait. Because right now I'm doing primitive triangles, but I could actually optimize it if I use triangle strip, right? Because I think I can start like at the center or something. Well, actually no, actually that should be fine, just triangle strip. Yeah, that should be fine. Let me show you what I mean. What? Rendering a GIF, maybe? Do we have a GIF? Do we have size GIF? Wait, that's not triangle. Triangle strip. Okay, do we have... Wait, no, we don't. Yeah, I don't have wait, I kind of do, right? So I have like one vertex, a second, third, fourth, fifth, and I can just loop all around. And it's gonna make a triangle with the center. Kind of. But that also means maybe I do need the center after all. At least one time. I need to make sure it's not cutting the mesh. I don't know about concave shapes. Cannot resist the classic that. Yeah, never mind. I'm just reading again. Okay. Let's try the triangle strip. Here we go, and now we're gonna just have... Wait, I guess I can just add every point actually. I don't have to loop like this. Technically I could just do this. Boom. Add vertex. Oh, that should be a vector 3, right? I mean... Okay. Okay. Pos equal this. So vector 2, I guess. So this dot x, this dot y, this dot z. Well, actually I don't have z. Okay. Can I array mesh? Godot create mesh 2D. Do I have... Is there like an API for 2D mesh? Is actually... Oh. Wait, actually that might be a bit different. To vector 2. Add vertex. Wait, what? But... Oh. What? Vector 2. Wait. It's not gonna work, right? Yeah, because it's expecting a vector 3. 2D meshes. Sprite 2D is 2 meshes. Yeah, no. Wait, actually. Create... Oh. Yeah, okay, thanks. I thought so. So I guess we're just gonna put 0. Because I mean the rendering APIs expect 3 dimensions anyways. So here we go. We have this, I mean that should be fine. We generate the normals, we commit. Okay, and then we have to assign it though, right? So wait. Godot assign array mesh. Add surface from add array from surface tool. I guess both. I want both. By calling its commit method, which returns the final array mesh. Oh, it returns an array mesh. So something like this. Commit. It does. What's flag? Oh, dynamic update. That's what I want. Bone waves. Oh. Yeah, if... Wait, what? There's so much. Empty vertex array. Let's just do this. Dynamic update. Is it like this to mark that the mesh data will use GL dynamic draw and GL ES? Should I do this? Maybe not. Let's keep it like that for now. So okay, we commit, and now we have to to show the mesh, right? So maybe add child. Maybe I can just add the mesh. Argument should be node, but is yep, of course. So we're gonna create sprite mesh instance 2D mesh instance. Here we go. Then we have this. We set the mesh, and then we add the mesh instance as a child. And now we should have a circle that's not in the middle. Well, that's not you know, around the points, right? But we have the circle. Wait, maybe it's actually too good. Why do we have a circle like that? It's too perfect. And it's not the correct size. Maybe it's just because the points, you know, changed, moved. Well, they're trying to leave each other, I guess. Yeah, if it becomes concave, then I'm gonna have to do something about it. Well, that's gonna be wrong. So, I mean, that's good for now, let's say. But then we want to update the points. We have a physics update, but this one is related to the rendering. So we're gonna have a new process. Primitive triangles. Wait, it should be primitive triangles. Surface tools. Oh, okay, it should be primitive triangles. Okay, got it, my bad. So let's do this. Well, actually, we can remove then, I guess. Base mesh. What do you mean? Oh! Is it not the right mesh.primitive type? Oh! Primitive... Wait, what was it? Primitive triangle strip? I mean, okay, let's go primitive triangles, I guess. So we can remove this. Well, we will. We're gonna have this, and then we're gonna have... Well, maybe not. Free... Rev. It's gonna be a vector or two. We're gonna have the next. And we're just gonna get this. We're just gonna get this. Just so that next I have vector 3, this.x, this.y, 0, 0. I'm gonna have the same here with next instead. And I'm gonna have the 0, or like the center actually. It's supposed to be the center. Maybe I can have like the average. Well, vector 2 equal 0. And then for every point, for point in this, I'm gonna... So that's a vector 2, right? And I'm just gonna do average plus equal point, and at the end I'm gonna divide by the amount. So we take the average. Here we go. Okay. What's this? Yeah, okay. Never mind. So then I use the average there, xy 0, and I'm gonna run, and I'm gonna have no errors, and I have a full circle now. So this is great. Now I just want to update the points. And yeah, let's just do that. Let's just do that. Wait, am I using the server? I'm not using the server, right? Wait. What? Rendering server. What am I using array mesh? Wait. So I have to do this. Then oh okay. Oh okay. I get the okay, got it. So then I get the OR_ID. So like mesh read equals, well, it's a read, right? I guess it's null at first. Maybe not. Okay. So we have this, and then we're gonna do mesh instance, or like mesh dot get read. Yep, get read. And is it saying something else? Well, I mean, after that we have to update the points, right? So wait, what? Instance or ID create. Wait, what? Obtain the mesh resource or ID. Oh wait, so I don't commit the mesh. Oh, I don't. Well, I mean, I don't get back the. I don't retrieve the mesh array. Is that it? I just get the OR_ID. Rendering server.instance create. So I have the instance. Assign the mesh resource to the instance. Hey Tanguy, how are you? Create a visual instance. Yeah, tell me if everything's good and you. Yeah, I'm good, thanks. Tell me if like what you wanted to test is going fine. I don't actually know like really what you're trying to do. Wait. Yeah, sorry, I didn't actually answer. I just put an emote. That was like, okay. I forgot. I should have sent something back. I'll explain you. I'll tell you later. Okay. So set base. We have this. We have trans. You know what? It's manage the life cycle. I mean, okay. Technically, maybe we want to do that, but for now, let's just update the position in a very bad way. Yeah. Okay. Update region should be good. Yeah, should be good. Should be enough. So wait, I actually can use this. So wait, I can create the mesh this way. Wait, never mind. Wait, that's just for the update, right? So I add surface from arrays. Wait, I do that? Anyway, so we have the mesh. Okay, this. Then we have get OR_ID, okay. And then we have rendering server.mesh surface update region. The size of the array has not changed. Yeah, okay, this is good. That means it's optimized. Let's just copy this for now. And process. Let's update. Whoa. So we have the mesh OR_ID. This is the first one. The surface index. Wait, we need that. Okay, let's just put the arguments like this. It's gonna be easier to see what's going on. So this is the amount of vertices, or maybe not. 2-byte array. So 2 seconds. I want to check. Oh. New positions. Is it... What is it? This. It's a packed vector free array. Okay. Okay. So let's go back here. Surface index. Surface tool. So I have the mesh, right? Do I have this surface index? Maybe, wait. What was that supposed to be actually? So we have this surface index is supposed to be an integer. Here. You know what? Let's just look at what the function says. But I actually can't go there. Let's go here. That's such, and we actually don't have it. Mesh update attribute. Wait. Region. So without the region. Okay, attribute region. Index region. Oh! Vertex region. We just want to update the vertex region. So what is the surface though? Offset is 0, data is packed. Okay, that should be good. So let's call it again. Well, here, I guess. So we have the OID. Then we have the surface. Oh. Oh, thanks. Yeah, wait. Let me look it up. Godot rendering server. No. Surface index. Yeah, I feel like this is gonna be a bit complicated. Next. What is it? Specific distinct part of a 3D mesh. I guess that's 0 then. Can contain multiple... Yeah, okay, we only have one surface right now. Right? We have the surface tool, right? So that should be 0. Let's just put this just in case we forget. So then we have mesh, surface, offset. Offset is 0. Yep. And then we have the data in a packed byte array. Wait, what? Offset and data. Let me do this. Well, actually I have to convert to bytes, right? So this should be okay. It should be alright. Mesh, oh, I don't need this. And yeah, this one is missing. Maybe something like this. Though it's a vector 2, right? And I need a vector 3, I guess. Cannot find member. Can you? Can you not? Godot array 2-byte array. To do packed byte array, I guess I just have to call the constructor. Whoa, something like this. And let's have 3D positions or something like this. I guess I made the thing kind of wrong for rendering. But actually, yeah, never mind. So, positions 3D, like vertices 3D, I guess. We're gonna have this, we're gonna look through everything. So we're gonna get this. We're gonna push back or like resize maybe even. Yeah, let's resize. So it's more optimal. I mean, I guess we should want to keep that vertex, that array alive, but that's fine. You have this, you have the resize, you have I equal this vector 3, this I dot x, this I dot y, 0, 0. We are assigning, and then we assign this, right? Okay, should be good. Standalone expression has no effect, yeah. Delta is never used, that's fine. Okay, is it going to work? I feel like this is going to crash, yeah. Yeah, I mean, I'm not, wait, what? Yeah, okay, yeah, that's not needed. That should be good then. Or not? Wait, it is. Wait, it's not. It's generating the mesh, but not updating. For some reason. So mesh, vertices 3D. So you have a lot of stuff, right? But it's not moving. It's not moving. I was wondering, is it maybe because of the referential? No, because it should move. It should move in any case. So what should I do? Mesh surface update vertex region. So I only have one. Well, I mean, I'm getting the OID, and then I have only one surface, right? Like if I check this, it's, you know, it's okay. Maybe it's like in 3D. No, it's not, because I see it in 2D. Wait, maybe not here. Wait. Oh, it's still running. Yeah, I see the stuff in 3D, right? I mean, I could recreate it, but I don't think that's what I want. So what when I call this? Doesn't work after the first frame. Oh, wait. Issue. Do. It works great when using arrayMesh.surface update vertex region. Does it? Not really, right? Does it? Wait, what? What even is this? What even is this? Let's just Godot update subregion. Well, update region. Texture 2D update. Oh no, I don't want to update the texture. Vertices. Mesh without recreating the entire mesh object. Ideal for dynamic stuff. I don't think I need to set a flag to false, right? Like to refresh, like to call a function, right? I just have to call this. Update one vertex at index I. So surface index. It's 0, right? Yeah, of course it's 0. Wait, rendering server.mesh create. Oh. Maybe I have to use this. Maybe I can't use the interface with the surface tool. I don't know. Mesh add surface from arrays. I just want some results quickly right now, so can I just array mesh update. I think it's array mesh, right? Yeah. Godot array mesh update. Every frame creates a new one. What the? Immediate mesh. I mean, I could. Ideally, I want to replace it with the rendering server, though. Yeah, C++ is better, of course. I mean, I guess... I guess we can update it every frame. It's gonna be so bad. Let's remove the OID for now. Let's just have the mesh. Where was it? Here. And I want to commit... No, I just want the mesh instance, I guess. Here we go. We have the mesh instance. And then we add as a child. And then we're gonna recreate it. Let me check. Okay. Create mesh, we could say. So we have out of this average, we generate, and we return, we commit. I can try this. Here we go, and then I just have to update the mesh like basically like this, right? This is, oh wait, this is kind of really ugly, but I could technically do this, right? So okay, this is technically correct. The only problem is the offset. Because it's in local coordinates. Is it? Wait, what? Yeah, why is it working that well, actually? Wait, why is it working that well? It's not supposed to work that well, right? Wait, what? What's the offset about? Key positions. Maybe I can use this instead. But it's not gonna change anything much, right? And I mean, over distance. Is it like changing global position? Yeah, that's not supposed to change anything. I mean, the first frame, I guess. It should change the first frame. That's it. That's not really what I want. Yeah, what's the problem with this? That's kind of sus. That's kind of sus. That's kind of working, but there's always this offset. So let's check this. But I actually don't have any... Wait, actually remote. Chain. Can I... Just... 2 seconds. Wait. Where's my... Here. So, okay, we have this. It's not moving. Good. So we have a lot of character bodies. What about the position? 9, 5, 3, 4, 6. Yeah, this is not moving. But I mean, that explains things, though. That explains a lot of things. Previous global position. Oh, right, yeah, I mean, okay, yeah, that makes totally sense. Yeah, well, okay, this is it. This is it. Hey, it's working now, right? Hey, here we go. So now I can have like some kind of slime, and it's gonna bounce, and it's gonna be fine, and it's gonna be great. Hey, here we go. Actually, what's this? Oh, never mind. That's good. Kind of. I feel like there should be like some problem if I bounce, because it's not taking into account concave shapes. But it actually seems to be fine, because it's really hard to get to a concave shape with this, except if like you do this stuff a lot, right? But right. And we have the little spheres. So wait a second. So we have some colliders, right? The colliders, well, I mean, we're putting like the points of the sprites, not where we have the colliders, but, well, actually where we have the colliders, but not at the extremities, right? So maybe we want to push a bit more in that direction. So we actually only see the slime. Because right now it looks like a car, right? Like an automobile. Kind of. Boom, boom, boom. Well, I guess I can. Never mind. Okay. Yeah, let's maybe hide the keys. Let's hide the keys. And it should look like alright for now. Or maybe. Yeah, let's open the overlay. Oh. Okay, so we have our sphere and it's bouncing. There's like the little thing there, but that's fine. I could make the collision shapes smaller, but I don't want it to go through. Wait, actually, I have to check this. Godot or 2D collisions continuous. By default or discrete. Oh, so that means it can go through walls. CCD in rigid body. Let's not do that. Especially with the amount we have. So okay, we have this, right? Hey. So now, what if I add some eyes, maybe? Should I add some eyes? Do I need some more dots, maybe? Well, actually, I need the curves, right? Because right now it looks like segments, right? The circle doesn't look really like a circle. I need the Catmull-Rams curve. Catmull, okay, we don't have this. Let me search for the formula. Catmull's curve. This. Kyosan. Spline. Special case of a cardinal spline. Oh, assumes uniform parameter spacing. Oh, okay. So we have mk equal, for tangents, chosen to be this. And then the following formula for the Catmull-Rams spline is obtained with this. The definition formula of cubic Hermite spline. So you replace. Okay. Can I just run formula between 2 points? Maybe? Four control points. Formula computes a point QT on the segment between P1 and P2. Okay. Acts as a control point. It defines the curve's tangency / slope. Do I really need that? Yeah, T is fine. Continuity, yeah. With more than 2 control points. Maybe it's like the next one and all of that. 0, 1, 2, 3. Okay, yeah, this is fine. This is fine. Yeah, this is the next one and the previous one. So, yeah, okay, should be good. Okay, so if I create mesh, so we have all the points already, right? So yeah, okay, this is actually different from vector 2. This is good, this is good. I'm gonna add new points. Probably. So. We have the previous and we have the next. Can I have the previous and the next? Oh. Oh no. Let me look at the formula again. All of this. It looks so long. I guess it's because it's a matrix, right? It's a matrix multiplication. 1. So minus. I can't even see everything. So yeah, okay, this is just putting into matrix form. We have the PK, MK. Wait, what? MK? Why is that? Oh, well, I mean, I guess they're calling that differently, but that's the same thing, right? PK minus 1, PK, PK plus 1, PK plus 2. And then we have, let's say, if we multiply, we have T3 times minus 1. So, wait, minus 1. So there, maybe? Wait. T3 plus this minus. Wait, so it's this one actually, but it's reversed. It's a plus instead of a minus. Plus t, and we have 1 times 0, so 0. This is this one. So wait, I might be kind of confused if the points are different. Because the order is not the same. Let me just try to get it here. Okay, here we go. So we have all of this. I mean, I guess I can just compute the matrix multiplication myself. Calculated as all of this. Okay. Tension and non-derivative. Okay. I mean, yeah, let's just. Yeah, I mean, this is the same, right? Actually, this is just the opposite way now that I look into it. Let's use the one from, well actually this one already has -1. Oh, it's like the vector, yeah, they're the same, they just have different tensors. Well, tensors of different, opposite um, dimensions. Well, yeah. Anyway, yeah. So we have 4. I mean, I need the previous in any case, right? And the next maybe, like next and next. Well, maybe we're gonna have P. We're gonna have, well, P1, P2, P3, and P4, and it should be fine, and it should be working well, and we won't have to handle different edge cases. So we have this, we have this, and we have this. 2, 3. So then we have the curve, I guess. So maybe sample Catmull run spline. Maybe I can actually spline dot new. No, I don't. So sample, we have P1, P2, P3, P4, right? I mean, I guess it's a vector too. Wait, well, yeah, if it's a vector too, then wait a second. No, that's fine. Yeah, that's fine. It doesn't. It's not about how many coordinates you have. It's about how many points. So then you have 1/2, like 0.5 times matrix multiplication. Wait, do I really want to compute that without paper? I mean, this is basically this, right? But the order is kind of tricky. So wait, let's multiply those two first. So we have this times pk minus 1. 1, 3, minus 3, 1. What? Yeah, we don't have that. Wait, we do? No, we don't. Yeah, because it's... Yeah, I mean, okay. Yeah, okay, we have to multiply this first, I guess, because it's... Like, the result is, like, just, a vector. Well, we don't have to, but... If we want to compare... Can I... You know what? Developed expression. I can't move to the right. Do I have to write that in Paint? Oh, wait. F3. Ja. Kite kan se Hyogen. What? I can read that? What? Wait, I can't really read all of this. Seigyoten. What the fuck? But I can read? I wasn't expecting that. So, okay, we basically have all of this. And F1. Okay, I should be good. Yeah, we have just all the functions. And every function is like 0.5 times something. So we have P1 times something plus P2 times something. Let's do this. plus p3 times something plus p4 times something, right? So then we have, oh, I guess we have t, right? So we have t, this is a float. And let's have, I guess t3 is the maximum. So t2 equals t times t. And then we have t3. I mean, I guess I could pre-compute some stuff, potentially, never mind. So t2 times t. And now we have minus t3 plus 2 times t2 minus t. And let's just go back to the line. Like this. p2. 3 times t3 minus 5 times t2 plus 2. And minus 3 times t3 plus 4 times t2 plus t. Yeah, a lot of formulas, but that's fine. t3 minus t2, I guess. I guess that's it. So now we have the spline. Hey, sorry for this long explanation. Well, this long, not even explanation. I'm sorry about this. But this is a curve. This is what's important. And now I can call this curve with p1, p2, p3, and p4. And I'm gonna interpolate, let's say j, in range. And this is going to be from 0 to 10, maybe? I mean, I guess we could have a while, so that the amount of points rendered is actually different depending on the distance. That could be an idea. But let's have this for now. So it's 10 in total. So it's going to be j divided, well, it's going to be a float divided by 10, or like precision equal 10. So it's never gonna be 10 at this rate. I have to do a +1, right? So it's gonna be 11 points. So let's go with this, I guess. Maybe, okay, should be good. Yeah, wait, yeah, yeah. So okay, we have this. We have the Catmull-Ram spline, and we return what is that going to be? It's going to be a vector 2. So p, it's a vector 2. And now we have to add this. Oh, actually we have to, oh no. We need to compute the previous point too. We need to compute the previous point. And we need to store all of this. We need to store all of this. Prev and next. I mean, I guess we can just copy what we had. We had prev, we had next. We can keep this here. We can keep it. But instead of global positions, it's going to be vertices 2D. Maybe. Yeah, vertices 2D. Vector 2. This is an array that we are gonna resize right away to prevent too much performance loss. This is that size. I mean more, right? Like times 10 maybe? And then we have I plus I times that plus 1. Let's actually do 10. Let's remove the +1 and let's add a -1 here for now. And we're gonna have vertices to the I times precision plus j equal p, and that should be it. That should be it, and then yeah, this is the precision. So now it's kind of clean. Well, cleaner, right? And now I should just be able to loop through everything again, but through the vertices 2D instead. Like this. And if I run... Oh. Oh, look at this! Wait, this is so juicy. Well, juicy is like it's a sphere, right? It's like a real sphere. Oh yeah, we can see that there's some problem if I move it really fast. Because it's not detecting, well, it's considered to be convex when it's actually sometimes concave. Right, like on the sides, or behind, especially. But it's like great. I like this. Kind of. It's a good start. It's a good start. And like cutting into... My problem is that... Wait, what? Oh, okay, good. My problem is that cutting a concave mesh into a convex mesh is kind of, you know, performance heavy, right? So I wonder if like there's some trick I could use. Maybe based on the fact that it's actually a sphere at first. I don't know. It is like looking kind of great still. And then we can add like some shader inside, which is great too. Green. I mean, I could have like a position. Let me think. So this is a mesh. Do I have the UVs? Maybe I don't, right? Maybe I do. But I'm not sending the UV information. Oh, maybe I can generate it through shaders instead. Yeah, wait, I can actually do this. Instead of generating the mesh on CPU every time, I can just run it in the shader every frame. Yeah, I guess I actually thought about it, but I kind of forgot. So if I want to do that, I want to send a quad to the shaders, and I want to send the... Oh, this is gonna be tricky. I want to send the curve. Well, all the points. Do I want to compute shader to do that? This is not going to be very optimized, but... UV, do I have... Set UV. Oh, I can set the UVs. I can do that. Okay. But no, we can't really do that, I guess. Well, I mean, we could, but... And I feel like that's really something we're lacking. We really need UVs. So wait, how should I map the UV to the circle? What's the usual method? Because I know that in 3D you have like a lot of ways. So it's just cutting. So I mean, basically in that case, the position of each vertex is the UV. You just have to normalize, right? Yeah. Yeah, okay. So now again we have the average, like middle point, I guess we could say. Let's... Wait, so if I want to set UVs, how do I do this? Wait, set UV is just a single vector. Specifies the set of UV coordinates to use for the next vertex. Oh, if every vertex needs to have this information set, you fail to submit it for the first vertex, this information may not be used at all. Okay. So for the next vertex, so I should be able to do something like this, this, and this, right? The middle point is always going to be 0, 5, 0, 5. So this is not really going to be a big deal. We could actually, yeah, let's just do this. And then for this, we're gonna have, I guess we want to compute the radius. Maybe I can just divide prev divided, well, not middle point. So what's the distance between prev and middle point? It's like something like this. Well, it's not a distance, but you get me. And I want the, not the absolute actually, I might want something not negative. Normalized. I want the normalized version of this. But I want to keep the direction. But normalized should be fine. Because it can be negative, right? So I get the normalized version. And I add plus 0.5 and minus. Basically, I try to remap it. Can I remap? Is there something like a remap function? Oh, I have actually. I do. I do have it. Is it just for floats? Oh, I think it is. Okay, never mind. So let's do a plus 0.5. Well, divided by... Actually, it's gonna be easier if I do plus vector dot, well, vector 2.1 divided by 2. And then I have like next minus middle point. And it should be the same, and yeah, it should be good. Please. Please. Well, actually, I can't even see the UVs. I forgot about that. Let's add a shader. Well, let's actually add a node, I guess, temporarily. Then we're gonna have material. No. Shader. New shader. Shaders. Well. Slime shader. It's already getting late. But I really want to have like some results in the end. So we have the fragment. And in the fragment we are going to have something like color.x, like R, I guess, equal UV.x. And same for maybe G. Then we're gonna have blue equals 0 and alpha equals 1, I guess. I mean, let's try this. Well, actually, we have to set it. So, material. We're gonna have chain, material, shader material. We're gonna assign the shader. Hey, here it is. We have the correct one. Looks good. Hey, what was that? Oh, thanks for the follow, Wax Nova. How are you? How are you doing? Not bad. How are you, bud? I'm good, thanks. As you maybe saw, I'm trying to make like some soft some soft physics, but I'm actually like trying to make like some kind of slime in the end, like some kind of creator. Let me just, why am I creating my mesh again? Create mesh. I mean, I guess this is how I'm creating my mesh. Okay. Yeah, here. Okay, mesh instance. So mesh instance dot shader. Yeah, what's up? Are you working on something yourself? Material equals material. Mat actually, I guess. Yeah, let's try. And we have. I'm procrastinating. Learning multiplayer. Oh, look at this! We have the shape. We got it. We have the right UVs. We have the right UVs. Wow! And it's bouncing. Blah blah. Ooh. And there's like, you know, physics, right? Collisions. That came out great. Thanks. It did. I still have some collisions that are bigger than the sprites, so as you can see, like there's some kind of gap here, but that's not that much of a problem. Now that we have the UVs though, we can do something, well, we can do eyes, basically. We can technically do something like eyes in the shader. So we have this, we have maybe something like circle SDF, something like that. Maybe it's not going to be a SDF, but well, here it is. We're gonna have 2D coordinates, I guess. So vec2, flat2. No, okay, vec2. Position, well, UV. And then we can have something like. Oh, Sigiman, drink. Oh, wait, I actually had like a very small amount of water, but just enough for you. How are you? Wait, I have to refresh my page because it says I have one viewer, but in the end I have like you two that are sending me stuff. So that's just already wrong. So wait, it's like return position minus. I mean, I guess the center is like 0, 0, right? But minus 0, 0 is just 0, right? So I should just be able to do this dot, well, length of that. I return. So this is a float. Length. Yep. So now I compute this. Let me actually. I guess I want a radius. How hard would it be to make it more fluid, like to have it slip through a space more narrow than this? Would be cool if you were making like a slime or something like you said. I can change the area of the thing, so I can make it like even more squishy if I want. Let me just try actually. not to make it more squishy, but I wanna see how it looks. Right now there are like some problems because it's not what. Okay, let's maybe do something like this. And I was saying it's not. Yeah, I'm considering the shape is convex when it actually can be concave. So if I try to put it in, I guess it's kind of too big right now. And I guess the points are not really good either. I mean, I guess yeah. Yeah, it's kind of buggy. Something like this. Oh yeah, this is looking great actually, look. Would be a neat game mechanic to be able to adjust your solidity. Not sure what the correct word would be there. Nice, yeah. 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 I mean, I guess another thing is that right now it's not. Well, I'm actually like, moving a single vertex instead of like the whole thing. I guess that's one of the problems too. But, like for example, right now, like the vertex was on the opposite, but when I have it in the right direction, it's like a lot easier to get into the hole. And yeah, the little problems. So like for example here, you can see that the shape is breaking sometimes, right? Like on the sides, like there's some kind of segment, like almost, right? It's because it's like not cut into convex uh, polygons, and it's concave instead. But I'm gonna handle that later. And yeah, it's trying to, go through, the collision because there's my mouse, right? But if it was just like adding velocity, then it should probably be kind of better. Like vertex steering in Blender. Yeah. I see what you mean. Kind of. But yeah, I see. But yeah, okay, yeah, there's still like... Basically, there's some collision points that are getting stuck. Maybe I should make it so if there is a point that is too far away, then it's trying to teleport. It's like a sticky balloon, yeah. You're right. Yeah, right now, if like there's one point that's like getting stuck, then it's like not getting in. Yeah, like right now, like there was like the problem. Like you can really see the problem with like the convex shape. I mean, right now you can see that there's a big problem. There. You have the triangle, right? Yeah, you have the triangle. That's it. I mean, you have other problems, but we're just doing science. Okay, so we have this. Let me have my smile. I want to have a smile. Well, a few... Well, some eyes, right? So we have the position. Let's say we have the radius. And we want to check if this is less than... Actually, never mind. Let's say it's going to be white by default. We should be... Yeah, let's just do something simple. Color equal vec for 1, 1, 1, 1. Is it gonna scream after me because it's not floats? No, okay, this seems fine. And if this is... Yeah, ifs are bad in shader code. Branches are bad, but, we can just do it for fun, I guess. So we have the position, that is UV. And I guess I want to subtract it to... Okay, so let's do vector 2 minus 0, 1, 0 to 5. And I want to check if this is less than 0. I mean, I guess I want the size in pixels actually, but that's gonna be fine. Maybe 0, 0, 1. If this is less than 0, 1, like 0, 0, 5, then this is gonna be color equal vec4. Well, black. Let's just have something black. Yeah, so I guess 1 actually. Okay, are you ready? Is that an eye? Okay, there's no eye. There's no eye. Why is that? So UV minus this. X. So it's from 0 to 1. Okay. And if it's less than this, if the distance it's in UVs. Let me just have 2, just in case, but it shouldn't be... Oh, wait, I actually know. I'm so stupid. I don't have a return. Let's put a return. Oh, I can't actually. Yeah, because it's in the fragment. Let's have something like this. Okay, what are we gonna have? Okay, we have an eye. We have an eye. Wait, we actually have an eye. Well, it's a little dot for now, right? But it can very easily become an eye. Let's do like 0.5 and L if, I guess. L if less than this, so like the opposite. Wait, what? Oh, else if, right? Yeah, I'm getting confused with Godot. Oh, egg yacht. Yeah, you're right. Oh, it's a bit bigger, but that's like definitely a problem. Yeah, okay. I get it. Yeah, it should be like 4, 4, let's say. Yeah, yeah, because it can't be negative, right? It's like 0, 6. Yeah, that's gonna be too big. Let's have this. Well, too big to close, I meant. Okay. And now we have... Oh. Something. We have something. Let me just put it apart a bit more. And then maybe we actually want to add an and it's not inside. Oh wait, actually, let's do I1. So this is the first I. Then we have I2, which is this. And now I want to check if this is less than 0.2 and bigger than 0.05, something like this. And I want to do the same for this one, but with I2. I'm missing something. I replaced something I shouldn't have replaced. Right. Oh, right. Wait, no. I don't know, actually. Oh, right, this one. Oh, yeah, I have one eye. But where's the other one? I1, I2. Oh, else, if. Okay, here we go. We have something. We're getting to something. With the eyes. What is this? I just want to add like some... I'm some... Wait, I just want to add some eyebrows or something, I don't know. It looks so funny. It looks like he's judging you, I don't know. So... Get there. Like a fox. It looks like a fox. Wait, oh, it's broken. That's fine, it's not anymore. I can just move it. Okay, that's kind of great. That's kind of great. And yeah, ideally, I guess I just want to move. Actually, you know what? I'm just gonna do that. Instead of moving a point, so mouse position, instead of doing that, I'm gonna do, okay, physics press, okay. I'm gonna do if input dot q, oh, input pressed, well, pressed, is key pressed, key A, then I'm gonna move every key, so for key in keys, key.x global position, that x plus equal, maybe not global position, I guess I want to set the velocity, right? Liquid panda, you're so right, you're so right, liquid panda. Well, yeah, I want to change the velocity, alright? So, I mean, maybe I don't even... Maybe I just want to set it here. Right? Like... For keys... I mean, actually, yeah, this is fine. And it's just velocity. Right? Oh, I mean, I'm setting the velocity, never mind. Global position... Wait, what? Wait, what? What? Oh, right, the target position. Oh, right, I'm doing that. Okay, you know what? I'm just gonna go here, in the middle of everything. And I'm just gonna do my thing, right? Like velocity plus equal. I shouldn't do that here, but you know. So it's like speed times delta actually I want. So well, actually no, that's just the velocity, right? So I should just be able to do vector 2, something like 200 minus. It's like some very, you know, fast debug thing, but you know, if it's working, it's working. I could even jump. Wait, let me actually jump. I wanna jump. Jump to the sky. Jump and see the cosmos. Oh. So 0, 500, 1000. Let's do this. So I have my little creator. If I go, wait. Oh shit, that works so good. Look at this. Can I just go there? Like down? Jump! Wait, it doesn't. I can't jump. Key space. Let me try to jump. Wait, I'm actually not multiplying. Oh, never mind. Yeah, this is fine. So if I press space. Oh, it's going down. Oh shit! I can actually bounce because of that. That's so great. It wasn't expected, but that's so great. Let me actually add S to go down. Because I want to go down sometimes. And I guess let me just put or. If this is W, I go up 2. Okay, we can try. Wait, I'm just flying at this rate. Yeah, because it's not like an instant thing, I guess, okay. Wait, can I? Yeah, okay, I can. Kind of fly. Can I go there, please? Oh, I don't have enough velocity for that. I'm just getting stuck. Oh no. I'm just getting stuck. Yeah. Go up. Oh wait, it's down. Okay, I don't know where am I, where I am. Oh wait, right, I can just left click to have it come back. Yeah, you can't. Wait. Oh. Can I just maybe go like very fast? Shit. Oh. So yeah, if I just, well, okay. Left click, and now you go. Wait, yeah, I can actually just lead it inside, and now I can just move like this. Wait, can I actually? Okay. Let me try something. Let me try something. Can I scale this? Maybe I have something like this, very small, because I actually want to have some fun. I actually want to have some fun now. Let's have a little level, shall we? Maybe something like this. Maybe I should just zoom out, actually. Let me zoom out. 0, 1. Then that means I can take this, I can increase the size even. Wait. Camera. Where is it? Oh, it's all of this. Oh, wait, that's actually a lot. Okay, so this, let's say. Yeah. I'm gonna have this. I'm gonna, well, let me actually do collisions or like environment, I guess. So the two are there. I'm gonna duplicate this. One. Wait, what? What is the environment? Oh. Oh. Uh-oh. Okay. Then we have something like this. We have this, maybe. Maybe not that much. But maybe something like this. We're gonna duplicate it again there, for example. And I actually like really wanna see how it's gonna look like. Okay, we can try this. Liquid Panda, here we go. Okay. So let's go there. Oh. Okay, it's going through. Can I just... Can splash? Can I... Oh, yeah, okay, I get it now. I get the problem. I understand the problem. Yeah, it's because there are like some holes between the... Yeah, okay, I get it. Make him crouch. I can't really make it crouch continuously. Well, actually, kind of. But basically the problem is that every little vertex, you could say, well, collisions are made out of a lot of little collision points. And since there are points, it just goes through, right? Like in a lot of cases, that's why it can just go like this. So I actually have to replace the collision by something I'm generating too, right? Because right now I generated the mesh from the points, from the original points. But now I actually have to generate the collision. I actually have to generate the correct collision. That's the problem. Oh, but wait a second. I just realized. That's gonna be complicated. That's gonna be complicated. So that we still have the... you know, the collisions with the walls, because if I recreate my collision box every frame, then you know, the points are just going to teleport, right? So I guess instead I want, yeah, okay, never mind. I just want something like rectangles. Just change up your level design so there are no points that can pierce him. No, there's always, well, never mind. It's not really that. Yeah, I'm just gonna replace the points by rectangles, I think. And that should be fine. Because the problem is, let me maybe open paint. Okay. Right now, the problem is that I have my shape, and I have basically the collision points are like this, like there's really a big hole, right? It's like really bad, right? And I'm gonna exaggerate a little because I think they are like a bit small, but it's looking like this, okay? It's like if something goes inside, then it's the end, right? There are so many people watching, but I wanted to go a bit early tonight. Oh no. But yeah, it looks like that. What we want is actually, well, I'm just gonna keep that. Is actually we want to create rectangles, not like straight rectangles, but like lines like this. Um, so that even if we update them later on, the points are not going to go through, right? So since they won't go through, it shouldn't be a problem if we, you know, update the rectangles. Well, I mean, I guess. Well, actually, there might be some problems, but but yeah, that should mainly be it. I think that's gonna be a lot better still if we do this. This is like a first step, I guess. Um, Another thing we could do is just, you know, generate like the whole, you know, collision as a circle, like as an entire, like the entire thing. But wait, actually, it should be kind of the same, and it should be actually easier to do that probably. Just change up your, yeah, never mind. uh, yeah, maybe I just need to change it into like a full collision. Hmm. What are your thoughts? Should I have rectangles or maybe just a huge collision? Because the thing with rectangles would work with. Actually, let's just have a big a big collision like this. Because if we have rectangles, there's going to be like a few corners, right? So it's not going to roll well. Could you do a circle collider that follows a couple of your vertices to scale it? I mean, in this case, I would just make my own, you know, the entire collision instead of the circle collision, probably. I mean, the circle collision. Maybe I can. Well, if we go with your ID, then that means I have, for example, the center, and I could have. Like, I could try to detect the point that is the closest to the center, and base the collision based on that point, right? So, like something like. Oh, something like this that touches this, right? Maybe. So, like for example, if we are on the ground, then you know that's these points are gonna go a bit higher, right? And that means the closest point is going to be this one. So wait, the hitbox would be like kind of shorter, like it would be like wait, yeah, maybe that wouldn't work because of that. It would be like something like this, maybe. So maybe that wouldn't be great because then we can just go through a lot of stuff from the sides. I'm still learning a lot. I mean, me too, right? We all still learning. Scale and offset. I mean, it's not gonna match anymore, though. Well, it's not gonna match the shape anymore at one point. I could do this, but then we have maybe like, I mean, then it's gonna be an ellipse, right? It's not actually a circle; it's an ellipse, and I mean, it feels a bit tricky. So probably just going with the full thing would be more easy, right? Like basically just follow every point and do the stuff, create the collision that way. And you just think a little bit. Yeah, I mean, it should be fine. I'm wondering about this, about how to connect each vertex. Like if we make a line, well, if we use a line, because if we use a line, it's going to be inside the circle, right? I mean, I think that would be fine still. I think that would be fine. What? It looks so funny. Can I go down? Yeah, yeah, okay. I wanted to have some fun, but it's just breaking the fun because of the collision. Okay. Yeah, I'm gonna have a full collision. It should be fine. I doubt you would really see it if it clips a little. I mean, I'm not sure about that because I mean, if it clips a little, then that means the collisions are gonna be weird and it's gonna clip even more. So I don't know. Let me just try to have some fun again. I guess I can have some fun as long as I have this. Okay, this is fine. Yeah, if we have all of the collisions inside, then it's not a problem. Wait, oh wait, I can. Yes! Wait, I can actually do it. Please, do the. Oh, right, it's getting stuck because. Oh, never mind, it's good. Can't wait. I wanna go again. Wait, I have an idea. Yeah, if I just duplicate this. Let me go. Select this one and go a little up. Then I duplicate this and I go this. I'm just having fun at this rate. Okay, so we have our little creator. Let's go there. And let's try to get down. Oh, we can! I miss so much! I miss so much! Okay, it's working. That works so well, right? It's because there's not like the thing like that, right? There's not like the straight. Well, the points are getting blocked by the ground this time, so it can't go like through the other side. I love the eyes. When it's like that, it's just so crazy. Okay. Okay, I'll probably stop for tonight though. I'm not gonna have the collisions for tonight. Well, it's like 2 a.m. Well, 2:30 for me. In the morning. So I have work tomorrow. I'm just my time zone is kind of bad, I guess, to stream in English, but well, maybe not actually. It depends. Um, Take care, man. Thanks. And yeah, just something. If you want, I'm actually on my other days. Usually, I'm working on a game because I'm actually a game dev. Well, believe it or not, I'm using Godot, right? And Yeah, this is my game. I'm planning to have like a demo for the Deck Builders Fest if you want. So feel free to check it out. I still have to update, like, make a lot of updates. So maybe, try to not judge too early, maybe, please. But yeah, if you can like leave a wish list, that would be appreciated. It's broken. This is a this is a nice way to finish the stream. This is perfect. So, Godot, do we have some people on Godot? Do you wanna game dev? Who's that? Is that Unity? That's Unity. Godot Wild. Wait, we have a Wild Jam. Godot Wild Jam. I like game jams. I actually stream a lot of game jams myself. I play a lot of games from game jams. Popular ones. I got 2 friends that will love that. Oh, great. I mean, that would be appreciated if you could like share or something, right? I guess the goal, I mean, I'm very far from the goal. But yeah, the demo is gonna be free anyways, so if you just wanna try it out, then just feel free, right? It's probably not going to be very long, and it's not going to be perfect polish-wise yet, but I mean, I'm gonna try my best. I mean, there's like still some polish that you can't really see with the pics, I guess, but it's, yeah, anyways. Let me raid this person that's like reversed. Starlight Lacuna. Lacuna Matata. And yeah, let's have some fun another time. Yeah, basically this project right now is the project I do when I don't have when I know I won't stream for a lot of time, or I don't know what to do with my other game. Well, I have to think about it, right? And yeah, this is just to relax because this is very relaxing, right? This is like really fun to play around. Can I just go up? I'm like really stuck right now. This is so bad. Ah. Okay. Anyway, thanks everyone. Bye bye.
Hello, Raiders. What we can do is, instead of
How y'all doing here?
removing
Welcome
the
in.
sprite 2D or disabling it, we can just say sprite.
Please tell me if
dot,
I'm pronouncing your name correctly.
Hello. Visible. Let's see here. Let's give you equals. Actually, we can just go ahead and
Shouty.
assign this.
What were y'all up to?
That should be fine. There we go. It says here that
So,
you were doing
right now-
some stuff
Ooh.
in. Ooh, you're generating a mesh.
Oh my goodness.
Squishing. Oh, hello, Axis Nova.
Hello, Raiders.
Just playing with slime and
How
Jodo.
are
Let's
y'all
just say,
doing here?
ooh.
Welcome in.
Progsy? Please tell me if I'm pronouncing your name correctly.
Hello.
Let's see here. Let's give you a shouty.
What were y'all up to?
There we go. It says here that you were doing some stuff in. Ooh, you're generating a mesh. You're squishing. Oh, hello, Axis Nova. Just playing with slime and Jodo. Let's just say, ooh, ooh, that's interesting. Picking up things, looting, trying not to make too much noise. So yeah, I'm currently in the process of making some systems for the wild cards. So the wild jam is fun because not only do we have a theme, we have optional wild cards that we can implement in our game. These are not required, they're just, fun things that can spice up your game. So the wild cards this time are probability, so adding some kind of random chance. There's also disease, where you add a debuff.
Oh wait,
and
the
there's
stream
also
is not